Hello students, today we are going to discuss about the aldehydes, ketones and carboxylic acid of the revision program. So from the level 1 questions, first I will discuss some very important questions are there. And the first important question from this chapter is alcohol condensation. Alcohol condensation reaction. So what is alcohol condensation reaction? The question is there, in the level 1 questions. Question number 7 actually this is. Once you see the question number 7, then you will get it alcohol condensation reaction. So what is alcohol condensation reaction? You know that aldehydes are ketones having at least one alpha hydrogen reacted with NaOH in presence of NaOH, and it gives the beta hydroxyaldehydes and ketones called as aldol alcohols, and further followed by heating, and it gives alpha beta unsaturated carbonate compounds, and that reaction will be called as aldol condensation reaction. Okay. So what is that one? Aldehydes are ketones. Suppose I will take acetaldehyde. Aldehydes are ketones. And we have to take 2 moles of aldehydes here, having at least one alpha hydrogen. This is a functional group and this is alpha carbon. These alpha carbon attached hydrogens will be called alpha hydrogens. So the compound or aldehyde or ketone must have at least one alpha hydrogen and undergo reaction in presence of dilute NaOH. In presence of dilute NaOH. Okay. And it gives, that beta hydroxy aldehydes. This is a functional group. This is alpha carbon. This is a beta carbon. This is gamma carbon. Beta carbon OH is attached, so that's why we will call beta hydroxy. This is the aldehyde. So beta hydroxy aldehydes are the bonds. Yeah. And followed by heating. If you heat this one, the condensation reaction takes place. Means removal of small molecule like water. And this alpha hydrogen is very acidic. And so that's why we write here CH2 as a CH. Then you heat, then water molecule will be. So this we will write as minus CH2. And now elimination reaction, and elimination reaction takes place and single bond is converted into double bond. So then what you get here? CH3, CH double bond and CH and CH2. Yeah. Again, this is functional group alpha carbon, beta carbon. Okay. So what we will call this is alpha beta double bond means we will call unsaturation. Unsaturated. Aldehyde is there, so that's why CHO2 means aldehyde. So we will call this is aldehydes. Okay. So this reaction will be called as alcohol condensation reaction, and important reaction. This is named reaction, and you will get in the final examination this question for the 2 marks. One of the important questions. Mechanism is not required. I said already mechanism in the classroom how you will get this product. So this is the alcohol condensation reaction. Once again, aldehyde. It is aldehyde is there in this compound. Alcohols are there. Aldehydes means we will write here aldehydes. This is alcohol. Alcohol means this is alcohol. So in this one, all aldehyde, we will take the AL from the aldehyde and OL from which one? Alcohol. So what we will call this is alcohol. This product we will call as what it is alcohol. If you take the ketone, then we will call it ketone. This is about alcohol condensation reaction. Aldehydes are ketones having at least one alpha hydrogen undergo reaction in presence of the dilute base and gives the beta hydroxyaldehydes or beta hydroxy ketones, and followed by heating gives alpha beta unsaturated aldehydes or ketones, and that reaction will be called as alcohol condensation. This is the first one. And the second important reaction is here. You know, Kenisaro reaction. Another one is here. Kenisaro reaction. So what is the Kenisaro reaction? Kenisaro's reaction. Another naval reaction. You know that in this chapter we have so many naval reactions are there, and which are very important. Okay. Now just opposite to aldehyde condensation. Kenisaro reaction is just opposite, because in the aldehyde condensation we have taken aldehydes having at least one alpha hydrogen. But here in the Kenisaro reaction, aldehyde without having alpha hydrogen involved undergo self-oxidation and reduction in presence of concentrated NaOH. This is very important. You have to write the line self-oxidation and reduction, or we can say disproportionation reaction. Okay. So best example for this one, formaldehyde. So formaldehyde, this is the aldehyde functional group. So it doesn't have any alpha carbon. So that's why it doesn't have any alpha hydrogen. So compound without alpha hydrogen undergo self-oxidation and reduction. In the aldehyde condensation Kenisaro reaction, we have to take the two modes. And we are dilute NaOH and we are concentrated NaOH. Okay. But sometimes instead of concentrated NaOH, they may give 50% of NaOH. 50% of NaOH treated as a concentrated NaOH. Okay. Undergo self-oxidation and reduction. You know that aldehyde undergo oxidation, acids you will get. Aldehyde undergo reduction, alcohols. So that's why one aldehyde undergo oxidation, it converts into acid. One carbon acid means formic acid. Clear? And another aldehyde undergo reduction. Reduction means you already know that. Reduction means you will get aldehyde reduction, you will get alcohols. So that's why one carbon alcohol CH3OH. This is an acid, but what medium we are maintaining in this reaction? Basic medium. Acid and base, what we get? Salt. So that's why sodium salt of potassium acid plus alcohol. And this reaction will be called Kenisaro reaction. Clear? And in this one, mechanism is not required. Mechanism only for cooperating, that I already discussed in the class. Just you have to write the definition of this Kenisaro reaction, and you have to write what is the products and what are the reactants. So aldehydes without having alpha hydrogen undergo self-oxidation and reduction in presence of concentrated NaOH, and it gives sodium salt of acid and alcohol, and that reaction will be called Kenisaro's reaction. Next one is HZ reaction, another name reaction. What is the HZ reaction? You know that acids having at least one alpha hydrogen, when reacted with chlorine and red phosphorus, and it gives alpha carboxylic acids, and that reaction will be called as a HZ reaction. Okay. See what is this one? Acid having at least one alpha hydrogen. This is a functional group. This is alpha carbon. It is having two hydrogens. Okay. So when reacted with chlorine and red phosphorus, and you know that alpha hydrogens are very acidic. So that's why one of the hydrogen is replaced by chlorine, and you will get RCHCl CO4H. This we will call alpha carboxylic acids. And this reaction we will call Hall-Walhod-Zalewski reaction, that is HZ reaction. Question number that is 9th in the level 1 question. Clear? Level 1 questions, question number 9 this is. Simple, you have to write just definition. Carboxylic acids having at least one alpha hydrogen when treated with the chlorine in presence of red phosphorus, and it gives alpha carboxylic acids, and that reaction will be called HZ reaction. Clear? And the next one is there, fourth one, Very important reaction involved in the Edwards reaction. Another important reaction. That is, you know, Edwards reaction actually it is not there. I have not given in the level 1 questions, but you have to add that one of the important questions. I forgot to give in the level 1 questions actually. So what is the Edwards reaction? Clear? And you know that whenever toluene alkyl benzenes, this is what it is known, alkyl benzene, when treated with chromyl chloride, CrO2Cl2 in presence of CS2. This is the reagent and this is the solvent. Okay. And you will get the compound here. One complex chromium complex you will get, that is CH and O. You know that this is Cr. One of the O is attached to carbon, another O is converted to OH because 2 hydrogens will come here. So that's why it is become OH, and here there is a Cl2 and 2 hydrogens are replaced, so that's why we have to write it this. Clear? And I said mechanism also in the class. Clear? But here mechanism is not required. Just you have to write what is the reactant and what is the intermediate and what is the final product. Clear? And now this we will call as brown color chromium complex. Or simply you can write chromium complex, which is brown color. Okay. And finally you have to do what it is, hydrolysis. Then this complex is converted to which one? Aldehyde. CH. Okay. And this reaction will be called Edwards reaction. Again I am saying here, I have not included this one in the level 1 questions, but we have to include this. Very important question. Then about toluene, this we will call as a toluene treated with chromyl chloride in presence of CS2, that is carbon disulfide, as a solvent, and it gives the here chromium complex, and chromium complex further hydrolysis and it gives aldehyde. This will be called as benzene. And this reaction will be called as what it is, Edwards reaction. 2 marks question. You have to further description to write the what is the Edwards reaction, and that 1 mark, and if you write here total reaction 1 mark for that. And next question is there here, Gutterman-Koch reaction. Okay. Another one is Gutterman-Koch reaction. Koch reaction. This is another reaction, named reaction. You see, so many named reactions are there in this chapter. All are very, very important. Yeah. And now, what is Gutterman-Koch reaction? Okay. And in this reaction, so there is a small correction is there in the material, and we have toluene, but it is not a toluene. It is benzene. In the material we have given CH. Just cut it this one. There is no means CH should not be present on the benzene. Question number 2, once you see there is a small mistake. Take the benzene and treat this one with the carbon monoxide and HCl in presence of AlCl3 and gives a benzene. Gives which compound benzene. And this we will call as a Gutterman-Koch reaction. Okay? See what is that? Benzene. When we treat with the carbon monoxide plus HCl in presence of AlCl3 and gives and this is what benzene. I have given there the material CH3. And next one. Next one is Clemenson reaction. Clemenson reaction. What is this Clemenson reaction? You know the aldehydes and the ketones. If you reduce the aldehydes, you will get alcohol. But if you use the strong reducing agent, they are converted to alkanes. Okay. So now here aldehydes are ketones undergo reduction in presence of zinc amalgam and concentrate HCl. Okay. Then these ketones are ketones or aldehydes are converted into alkanes. Means what it is? The CO group is directly converted into CH2, and for that one we have to use the Clemmensen reduction. If you use the Clemmensen reduction, which medium we are maintaining here? Acidic medium. So reduction in presence of acidic medium, that is Clemmensen reduction. Okay. And another reduction you already know. What is the another one here? Wolff-Kishner reduction. And same, this is also, I said these are important reactions. Same, aldehydes are ketones. Take the aldehydes are ketones in presence of hydrazine, NH2 and H2, in presence of basic medium, ethylene glycol. Ethylene glycol is a solvent. Ethylene glycol is a solvent. Okay. Same, what will happen? You see, C double bond O is converted into CH2. Here also what is there? C double bond O is converted into CH2. Reactions both are same. This reagent can also be used to convert the C double bond O into CH2. But what is the difference? The difference is Clemmensen reduction is used in presence of which one here? Concentrated HCl. Means what it is? Acidic medium. Clemmensen reduction is performed in the presence of acidic medium, but Wolff-Kishner reduction is performed in presence of basic medium. That is the difference. Right? And this is the what is not here. Wolff-Kishner reduction, and this is what is not here. Clemmensen reduction. So both are gives the same products. Here also what it is? Alkanes. And here also what it is? Alkanes. And this is another Wolff-Kishner reduction and Clemmensen. And another one, you know, very important reaction. So that is the issue number 1, question number 6. Explain the mechanism of addition of HCl to the carbonyl group in presence of base. See the question number 6. Very important question and guaranteed question for your examination. So what is that one? Addition of HCl to the carbonyl compound. Okay. See what is that? Question number 6 from the level 1 questions. Clear? So carbonyl compounds. You know carbonyl compound means C double bond O is the functional group, and treated with the HCl and gives in the presence of OH minus. Okay. You will get the compound here OH and Cl. Cyanohydrates. These compounds we will call cyanohydrate. Okay. What is the mechanism? They will ask here to write the mechanism. So 3 marks question this is. Involves 3 steps. Okay. And what is the first step here? Clear? Step 1. You know that HCl is a weak acid, because you already know that carbonyl compounds involved in the nucleophilic addition reactions. Clear? But you know HCl is a weak acid. So weak acids cannot give the or cannot generate the nucleophile easily. So that's why to generate the nucleophile easily, and we have to use the base. What is the acid here? HCl. First step here, you know, formation of nucleophile. Formation of what it is nucleophile. How this nucleophile will be formed? And you know, HCl plus base you know that OH minus. And you know of what concept? Base always accepts the proton. So OH minus will accept the proton. Proton means H plus. When it takes the proton, these bond electrons will come towards the carbon. Then what will happen? OH and H plus. OH minus and H plus. You will get the what? H2 plus. What left here? This carbon is gaining electron. Gaining electron means carbon will get the negative charge. So Cn minus. And you know this negatively charged species we will call as a nucleophiles. This is nucleophile. So that's why we will call this step is a generation or formation of which one over here? Nucleophile. Okay? Formation of nucleophile. Okay? And this is the first step. And the next one is step 2. So after generation of the nucleophile will attack on the carbonyl carbon. You know, attack of nucleophile on carbonyl carbon. Okay, and you already know that C double bond O. This is the C double bond O. Okay. And here which one is generated? Nucleophile, that is Cn minus. Yeah. Now you already know that. So carbonyl compounds involved in the nucleophilic addition reaction. So you know oxygen is more electronegative, so that this bond electron will shift towards the oxygen. Oxygen is gaining electron, partial negative charge. Carbon is losing electron, partial positive charge. Okay. And you know that negative and positive there will be a bond. Attack takes place. Negative will attack on the positive. Clear? Then what will happen? You see, when it attacks on the carbon, this bond electron will shift towards the oxygen. Then what you will get? You see, this is two bonds on the carbon. One is oxygen. Oxygen gaining electron. Gaining electron means charge, negative. And carbon is attacking on the carbonyl carbon, so there will be a bond. This is clear. And now this is the intermediate, and this carbon is, you know, all single bonds are there. So that's why which carbon it is? sp3. So sp3 carbon means what is the, you know, shape of this molecule? Tetrahedral. This is the intermediate. Tetrahedral. Okay. Now this is the second step that I said, the attack of nucleophile on the carbonyl carbon. So we got the here tetrahedral intermediate, and now this intermediate is the third step, because it is oxygen is having negative charge. Oxygen is having negative charge means it try to neutralize its charge by accepting the proton. So that's why third step is addition of proton. Clear? Now you see second step, and O minus and Cn, and it takes proton. You know that oxygen is having negative charge, hydrogen is having positive charge. Negative and positive, there will be a bond formation. Then what do you get? And here OH and here Cn. That we will call cyanohydride. Okay. So this is about what it is here. Mechanism of addition of HCN on the carbonyl compound in presence of base, and it gives what it is cyanohydride. So it involves how many steps here? 3 steps. Each step carries 1 mark. So that's why you will have 3 marks for this question, definite question in your final examination. Okay? Formation of nucleophile by the base, and you are getting nucleophile here. After generation of nucleophile attack on the carbonyl compounds, and you will get the tetrahedral intermediate. After then, addition of protons takes place on the tetrahedral intermediate and gives the cyanohydride. So this is about what it is. Addition of nucleophile on carbonyl. So next well-known named reaction, that is Rosenthal reaction. Okay. What is Rosenthal reaction? You know that acid halides undergo reduction in presence of palladium BaSO4. It gives aldehydes. This reaction is used only to prepare the aldehydes. Clear? And plus H plus C HCl. So ketones cannot be prepared by this method, only aldehydes. Yeah. So what we will call this is acid halides. So addition of hydrogen we will call reduction. Okay. So that's why we will call this is Rosenthal reaction. And this is very important. What catalyst you are using in this reaction? That is palladium BaSO4 and gives aldehydes. This is what we will call aldehydes. Okay. So now if you take any simple example, CH3 C double bond OCl, what do you call this is acetyl chloride. Acetyl chloride, when undergo reduction in presence of palladium BaSO4 and gives acetaldehyde C double bond OH plus what we will get H. This is we will call acetaldehyde. In the same way, if you take benzoyl chloride and more reaction, H2 palladium BaSO4. Simple. What is the reaction? How to write? Remove this chlorine, add one hydrogen here, and the H and Cl will be used as a HCl. This we will call benzoyl. Instead of hydrogen is substituted, chlorine is substituted by hydrogen. Then we will get this. This reaction we will call Rosenthal reaction. And another reaction here, very important reaction, esterification reaction. Esterification reaction. What is esterification reaction? Acids and alcohol react together in presence of acidic medium and gives esters called as esterification. Acids, general formula, you know what are the acids? C double bond OH plus alcohol. You know general formula of alcohol is ROH. Because here also I have taken up, so to differentiate, I have given here R gas in presence of which medium here? Acidic medium. Yeah. And it gives here ester. Simple. What you have to do? Remove the water bond. Yeah. Then combine both. What you will get? R, C double bond O, and O are dash. This we will call as ester and plus H2O. Because what do we have in here? So this reaction we will call as a esterification reaction. Simple take any another one general formula. I will take acid, acetic acid I have taken. What we will call this is acetic acid. And ethyl alcohol I will take C2H5OH. This we will call as ethyl alcohol. In which medium? I am taking the N acidic. Then what we have to do? Remove the dust. Write the product. CH3, C double bond O, combine this O and C2H5 plus H2. This we will call as ethyl acetate. This we will call esterification reaction. Yeah. And these are some important questions from the level 1, and in the next class some other questions from the level 2. Okay, we will discuss level 2 in the next class. Okay, thank you so much.